Hi, my name is Vitaly Pasternak. I'm going to be giving a little bit of an overview of the DIY character viewer and various features here. So, um, this is the content library. It lists all our character types, which are effectively a collection of character animations, transition information, and hints about what appearances are valid for those. So when we first start up, we've got a default soldier, soldier 17, but just a quick overview of some of the other content in here: camels, chickens, cows, dogs, fish, sheep, and lots of different types of people. Um, so back to the soldier. Um, each each character type can have a collection of appearances, uh, and those are actually created via a whole bunch of different sub pieces. The first one is pretty much the basic body, and then the head. So a whole bunch of different heads. Some of these are captured with photogrammetry, some of them aren't. And then a hand item. So, oops, I'm loading this right now. So there's a whole bunch of different weapons. You'll notice the hands move via inverse kinematics to try to pick the right, a reasonable location for the hand. Not everything is guns, um, and there is also additional equipment that can be used. Let's go back to a regular weapon. So if we want to give this person a backpack, these are different additional shape sets that can come in, and each one has a slot, name slot, so you can only have one of each. If a person's wearing the right kind of helmet, it's sort of your job to pick an appearance that has the right helmet. So the default soldier does. We can add different items to that. There are filters on most of these pieces of user interfaces. Effectively, type in male here and it will just show me the various men. I could type in Asian, same thing. There's an additional set of filtering that each base appearance has like a list of nationalities, and that is used to build up this combo box. So it can male and female. Most of them are men. Country, there's children and use for some of the character types, and here's races. So that's actually coming out of a little string in the appearance type. So the structured button, actually, each weapon has a weapon type. Rifles, baton and shield, binoculars, tools, grenades, and this injured soldier is for some wounded carry thing. A couple of handguns. The important thing to realize about this is that each weapon type can indicate a different animation pose to use for the default generic standing, as well as other animations. So if you need a new weapon type, you can make one and then you assign that item to it, and that can give you a different baseline behavior and posture. And I'll get more into that when I go over the next piece, the motion editor. So there's lots of animations here. There's walking, walking and aiming, stepping, and again, a little bit of a filter here. There's also transition. So I just picked prone aim, and there's an elaborate transition network behind the scenes that allows the character to pick a reasonable animation to play those transitions and not just lerp directly into that. And that, helps create the sense that it's a real character. There's also a number of gestures which are specified in config files. Again, some of these may not be appropriate depending upon what he has in his hand. So we may want to. Some of them are full body gestures, some of them are just upper body. Most I think are upper body. So his lower body can continue walking while his upper body plays that animation. Not the most smooth. Now, many of these actions are just directly playing back an underlying motion file. Not all of them are. So for example, kneel aim, let's give him a weapon, allows you to aim. It actually has a number of different poses which we interpolate between procedurally to give him an animation that will aim in different directions. If the character is properly configured, we can show his aim vectors. That's direction shooting, fire. So let's turn that off. Now, more complicated than that is our locomotion animations. So again, we'll talk about this more in a little bit when we go through the motion editor, but effectively this is an animation that this is an action rather that wraps many other animations under the hood. And there's a little bit more foot sliding, but effectively it is procedurally trying to create an appropriate animation by blending other ones together. So, at this point he's playing kind of a walk animation, but it will get faster and faster, and eventually it will switch into a run animation. He will put his gun more or less down because it can't quite run and aim at the same time. And so this is a way, DI Guy at one point had many different animations like walk aim back. This was a way of hiding that complexity from the end user so they didn't constantly have to pick an appropriate animation and build lookup tables. Instead, we just had, here's the velocity I want. So some next pieces. This is LOD visualization. There's a couple of different ways to look at this. You can see that we're just lowering the levels of detail. We could also change the shader quality from bump maps to per pixel lighting to per vertex to completely unlit. So these can help with performance. It also just gives us a sense of what's there. By default, we have our shadows on, and we can change the direction of the light. We are currently looking at, his position. We can orbit the character. If we want a close-up of his face, we can switch the lookout link and pull in and pull out. So back to the position. This now starts with a little bit of a debugging for structure. So there's a whole different shader, and it allows us to walk through the different maps. So this is the diffuse map, sometimes called the albedo map. Some of the materials can have a different baseline color. I guess right now that patch does. This is the result of the diffuse mathematical calculation. this adds in the normal map or bump map, depending on what you want to call it. This is the emission map. This character doesn't really have any emissive textures on it, but it is possible to have them. I think people like the flight deck crew, that's what FDC stands for. Right, so this character has emission on the wands to give him some light there at night. So most of our characters have ambient occlusion maps. And so that's the ambient contribution. Here's the specular material at this point. That's pretty uncommon, and most of the time we drive it just from a specular map. Oh, that looks wrong. Well, guess I'll have to ask about that. And this can also have a metal map at this point if you're using PBR, physically based rendering. I believe the FTC character, let's go back to those guys. Yeah, so this one is more driven by the metal pipeline, the PBR pipeline. Shininess, different parts of the physically based rendering math pipeline. So here, this helmet's got a little bit of a golden hue on it. Whether or not physically based rendering shaders are used, because we have a lot of old content that's not PBR based, you can see the resulting mathematical contribution on the specular contribution. The normals, sometimes it's helpful to look at this in case there's mathematical transforms that aren't working for one piece of the geometry but are for the other, and so we wind up with mismatched lighting. This is the normal map. This color is because it's flipped. The normal map can have two different directions. The geometry can wind up calculating different. There can be a flip in them. Here are our tangents. Not really great for visualization, but again, this is necessary for bump maps and normal maps. And if there's a hard seam in this, it might be something you need to look at. Here is vertex weights. So the light purple here, or red, is an indication that this is a skin model. If there's only one weight, it's kind of light blue. And then as we have more bone influences, the colors change. So you can see that these are the areas that are going to flex more and not be sort of rigidly attached. And sometimes this is useful for debugging if you want to understand what the model looks like without the scan weights applying. This is just the shadow contribution. This component map, I'll talk about this in a little bit, but it is mostly for civilians that have different outfits and the ability to color shift them. The best way to see this is go into army mode and uncheck this and say use variation. So you can see that the component map is used to make what looks like all the same characters look a little different. This is how much the component map should contribute. You can fade in and fade out. Let's go back to the soldier. Again, this has metalness because this was flagged as PBR. The rest of the character does not, and so it is red. Visualization of the UVs and a visualization of the texture density. Ideally, all of these would be about the same color, but they aren't always. And that's it on the shader debugging here. So character editing. So if you're an artist and working on this, there's a lot of handy options here. You can reload the textures, you can reload the geometry, you can reload the appearances if you're editing the files on disk. You can reload the shaders if you're editing those, as well as weapon data and animation. Oh, the load animation data mode is for testing delayed animation. We don't always load all the animations at once, so this was a way of generating some warnings. I don't think that's going to be used very often. But if you're an artist, very often you want to do reload textures and reload geometry. And the idea here is that you'd be editing in one product and not exiting frequently. You'd just be reloading it. Army mode, so this was shown a little earlier. This allows us to see lots of different characters at the same time, lots of different appearances. It is limited to the current appearance, so all these characters have the same appearance type. You can have them have a random head. You can randomize their heights. I explained the use variation. Use appearance names. Oh, okay. I guess that's something we added in case one of the appearances looked wrong. This was a little bit of a debugging aid to let you figure out which one it was. There's also a pretty elaborate instancing system here, which is on by default and helps for faraway characters minimize the number of draw calls that is happening. So if I turn off the appearance mix, you can see that the nearest characters are in fact drawn non-instanced. So there's some benefits and downsides to that. If I change the instancing LOD, you can see that the even more characters are all instanced, and it goes faster. You can probably see that the lighting does change on the characters. Currently, instancing does not support bump maps, but it probably could be added. So, going back down. Again, these are sort of profiling options to use the multi-thread pipeline to asynchronously load textures, to delay motion loading, to pause characters. There's an option to activate Tracy and control if the CPU is being captured, and animation load management. That's if you're trying to have hundreds of characters animate and you want to lower the frequency of the animation update in characters far away. DI-Guy is very efficient. It's usually not quite necessary. So, oh, and one more thing I forgot about, the render passes. So some objects are have transparency in them, and those are going to draw on a second pass. And sometimes there are issues. It's expected to be that these are drawn with alpha blending on, and so we have the option of seeing what getting rid of the too fast rendering would look like. There may be some failures on transparency, especially if you're talking about vehicles with glass. But yeah, this is a way of just sort of sanity checking which objects have transparency and which ones don't. Okay, next user interface I want to go over. I think we pretty much covered most of the network settings. Sorry, content library. So for network settings, this is really meant to allow you to test DI-Guy into another product, networking product, and sort of make sure that basic performances work and that we are federating decently. DI-Guy scenario is another way of doing this, but it seemed like it wasn't the worst idea to allow us to do this inside the character viewer. By default, this doesn't do a conversion, usually you want to be in flat earth. If you click join exercise and load up, Mox Vantage rendering engine, you can see a whole lot of people show up. If we mix people up, you'll see that will come over the network also. Just takes a bit of time. So you get the picture. It's a way of testing how well you're federating. If your network packets are coming in well, you can also let's get rid of some of these guys. If I just want one person, I can also turn on DIS loopback, scoot the guy over and see how well he performs. We can add, we have a number of packets, so we can see when data is coming in. So now there's some information about when the action came in, when the networking layer has informed us something's changed. I'm just, generally able to sort of do a simplified debugging of our network output and input. So that is the network settings. That is some of the debug information that we have available. There's a bunch of other sort of interesting things that you can test. If you are publishing without custom PDUs, which we are supposed to do, I think you can either do custom PDUs or DI-Guy state, which is a VRLink, modern VRLink thing. But if you're not sending those extra data, there is a model map editor that allows you to assign septets to all the different characters and see what our incoming and outgoing mapping look like. Just be aware of one thing is you need to explicitly save it and then hit reload there. Well, nothing is perfect. Okay, let's try that again. This is the geometry viewer. So this winds up exposing all of the internal pieces of data that are contributing to this one DI guy, and then attempts to display them for you as opposed to like running through a lot of configuration files. So we have various summaries, information about the different levels of detail, how many triangles each one's using, how small they are relative to the parent one, how many draw calls, the various files that the character consists of, a weapon, the flash, articulated hands, helmet, head, body. So earlier I was mentioning that we had extra configuration data that was allowing us to filter in the content library. That's displayed here. If you want to edit that, you have to edit the configuration files. We also have the concept of base appearance, where this character inherits from another appearance. It gets most of the parameters, but not all, but then can overwrite some of the parameters. Character is currently using an M4. If I change that to an M60, you'll see that that data does get updated, and weapon data and munition type have some specific meaning for weapon configurations. There's the idea that a character has a quality level. We've identified the character has transparency and bump maps, which means that they will use a nicer shader and two-pass rendering. actor. So this is just sort of like handy information that we've pulled out of the character that we're trying to show you. Link is another name. I think most of the time games would call them bones, but DI calls them links. They have index. This one has got index. Oh, they all have indices. I guess that was for debugging purposes at one point, and was handy to show. So a character consists of a skeleton, and that skeleton can be created either via a configuration file or by reading data out of the actual mesh. So we will procedurally create the bones as best we can. So there is a muzzle in this piece of geometry that specifies where it should be, and a rifle joint, and it kind of looks at the body for that attachment information. And right, so we try to procedurally create characters as much as we can based upon data coming off of 3D Studio Max, FBX files, and DAEs, but historically we did have a configuration file that actually described the character's skeleton. So each piece of geometry that is attached to the character is called a shape, and the shape can actually consist of multiple meshes, and there's two types of shapes, skinned and rigid. The skin shapes are almost always connected to the position, and they get the information for how they should move, bend, and attach. That information is driven by the skin weight data. And so we got the shapes. There's an option to, when you select them, that it should highlight it. Most of the time that the skin animation, the skin data moves the actual underlying mesh vertices. So here's sort of where it exists without the skinned information, and here up there is where it is. We've wireframed in a little bit of extra detail. Same thing for the helmet, same thing for the arm patches, but as we've got lots of shapes, it gets a little handy to be able to see where they are. So that's the rank. And we can turn them on and off. If we want to just understand better about how this thing is configured. So there are a number of shapes, and they can be present for different amounts of LOD. So the body sticks around the whole time. The head, there's one high resolution mesh in this case, and then there's LODs 2 through 4, and after LOD 4, the distinct head disappears, and there's just a sort of a shared head for all those characters. So it saves a little bit of performance, it drops the draw call. So you can see here, like, the patches, for instance, are only present. This is a right arm patch, a left arm patch. They're really only present for a short amount of time, 2 LODs, and then they fade away. Versus there's also a name label. So there's lots of little patches. We try, since there's overhead for having them, we try to make them disappear as soon as we can. And so these are all skinned objects, so they're all attached to the link position. Now here's data about the general character. Most of our skeletons, the initial base joint can translate, but most of the time your arm doesn't change its length, and neither does the DI guys. So it has a fixed translation, that's what T is, and that is the offset that we are getting out of either the configuration file or 3D Studio Max. We also have different hands that can get switched in and out. So you can see, let's do the other hand. This is usually driven by animation data, but these are all separately posed hands, and we can use them for signaling. So this idea of this hand model comes from the animation data. And then here's the palm joint and rifle joint. The rifle's attached to that, and you can see a little bit of a warning that these are very high polygons. And again, the muscle, I forget if there's a specific number. Right, 64, I'm not sure, I don't remember why exactly, but that turns on. So when you fire the weapon, this switch, just like these, are adjusted to show this extra piece of geometry briefly. So significantly, this rifle is a segmented, rigidly attached model, so it is rigidly attached to the rifle joint. So going back a little bit, if you're interested in editing this system, this gets a little bit more elaborate. This is actually, you're able to edit the geometry. So, 3ds Max and Maya and the other authoring tools that we have, they don't export all the data we needed, and in some cases we wanted to do a bunch of customization on these meshes to better suit the runtime needs. So the best example is probably our material state system. So we actually are able to reuse this baseline mesh with many, many different textures. Here is a complete list. It takes a little bit to open because I think it sometimes is populating that. Here's a complete list. So this same character is used for the Dutch, the Polish, German, Singapore, Belgian, Australian. So this really helps in terms of they can all have the same UV layout, they're all shared. We can reuse the mesh, we only load the mesh once. There's just various extra data here, mostly for debugging purposes or when something goes wrong. Here's all the bones that we pulled out of this character, information about the lookup table that we use to map bone animation data to links, and then down to the video card for animation indices. And there's a couple of editing options there. Most of the editing options are here. So very often what happens is that we want to add a new custom appearance. We will add a new state and then specify, okay, well, the spec map and the normal map is pretty much the same, but it needs a new diffuse map. So let's see if I can open this. That little button opens it. So this is apparently a Chilean soldier uniform. Everything else stays the same, and so it becomes fairly easy to add a new soldier outfit. But while reusing the mesh, the specular map, the normals, and there's configuration data that specifies which one to use, which we'll get to in a little bit. So that's sort of what the add new state and edit state is. I think I'll talk about the component map system, the variation system, a little later. It's a little bit more niche. And you can see all the various switch states here. There's information about the different nodes. This is a flat hierarchy. If you want to know if you want to see what DiGuy has extracted in terms of the parent-child relationships, we've got this body, the root node, which is multicam, and body LOD1, and there's a group, there's a geo, there's a mesh. You know, so we effectively have a file that has a number of things exported. So it can be handy if somebody exports this data and forgets one of these items and you get a warning about it. You can go in without needing to reopen 3D Studio Max. You can kind of go and check, okay, what does DI Guy think there are, and you know what nodes are there. Oh, right before I move on, over here, this UI allows you to actually switch through the various lists of material state swaps up there. So that can be a little handy for preview purposes. Yeah, some good colors there. Okay, so the next big complicated user interface is the appearance editor, and this is really for editing configuration files. So if the geometry viewer was good at like letting you understand how we collected all these different pieces and built a character in runtime, the appearance editor is really trying to show you what the configuration data was that helped build the character. Now there's two halves to this user interface. The top one is providing user-friendly or attempts to provide graphical user interfaces, a GUI, for editing a number of these parameters. So for instance, let me find something that, bounding radius. So this is something that is very nice to actually be able to see. I can drag it larger or smaller. Most of the time the characters are about 1.5. And that's a radius that's actually attached to the base joint. The other base joint also is your pelvis. And so as long as it's attached to your pelvis, you know, you don't usually get more than 4 feet from your pelvis in terms of the bounding volume. So so that's a reasonable value. But there are just the ability to edit some of these things, you know, to see where various bits of data are. This is a connection point. This is where a certain rifle effect shows up for a headlight. Probably easier to show. Yeah, there's a little runtime editor, local or world. This is the IK location. Let me hide the bounding volume. We only need that. Some of the things get turned on and then you have to turn them back off in the visualization, but this is a real-time editing of this IK offset on the character's hands. The animation data actually specify whether or not it should be used, and you know, you can pause the data here and it gets saved out as part of this M4 weapon data. So you can see that we're editing this, it's updating this, and there's a whole bunch of different things we can edit. We can go and look at his body, select it, see what actor it's using, see what equipment actor it specifies, see what multicam. I guess I didn't really explain the equipment so well, but maybe I'll come back to that. See what source file. Is it a base shape? A base shape means, does it say here? Shape replaces what's currently attached to link. What's currently attached to that link. So in other words, if this is a base shape and there's something else already on the link that this thing is attached to, it will replace it. This was more important when we didn't have skin characters. We now use a mix of is base shape and this class type. Fade out LOD and equipment. So let's see, for patches, fade out LOD is true. So that means that as you move a little bit further, it automatically hides those patches. It uses sort of a fraction of the LOD Here is the unit for the guy. So this is a piece of geometry and a texture atlas that has a list. If you go to the material state for the patch, you'll see that it points to a specific configuration file that lists a whole collection of patches. And so we have a patch here, a rank patch. These are, I guess I've done a poor job of explaining this. These are sort of testing purposes. First name, we're very informal here. You can also, modify damage state parenting. So these are just sort of like testing purposes. And again, like the fade out LOD. So, I get this far away and it fades out. And so whatever the last LOD is, it fades. So that's what a lot of these different pieces are. The material state override is the same as we were discussing earlier. It lets me change what the base material of this is. Having pointed that out, now the idea here is that you can edit this, but it's actually editing this appearance. So if I go down here, I can see these various bits of information. If I were to activate the shape sets and start, well, I guess if I go here, you can see as I edit this, right down here, it is getting updated with the new value. So the way this appearance works is that there's extra data. You can say for this character type, use an M4. For this character type, default to an M4. For this appearance, I want to switch to I want to target this shape, and I want to use the Chilean desert. So even though this shape set, it says shape set here, this material override is really a part of the appearance. So I can edit things up here, and it will update them in here at runtime. Now, let's say I want to actually edit some of the data in here because there isn't a good editor up here. I can actually go and type in here. I can modify this, change that to 0.3, change that to 0.5. I could add or remove things. I could copy paste them if it would make sense. Very often for LOD configuration, it makes sense to just tweak some of these. Oh, for LOD1, I want to point to LOD1. Fine. LOD2 points to LOD2. But I've decided that the character should just end at that point, or the head should disappear early. I can just hit cut, hit reload. The character gets recreated, and poof, he has no head. So this is sort of a way of having your cake and eat it too. You don't have to search. It shows you where each one of these items is coming from in terms of the configuration file, but you're not sitting there searching for it constantly. It's just attempting to put all of the information in this one user interface and reloading it every time you hit reload. Again, if you start editing up here and don't hit reload and then edit up here, it will blow away the contents of here. So you have to understand the workflow a little bit. You can also create a new appearance, either a body or hand or a head appearance type. You can add a shape set. They'll show you all the valid shape sets. The idea here is try to minimize the amount of user error from typing. If you're using the configuration files and every time you type another line, you have to reload the character viewer, you're going to have a lot of errors. But if you work in here and can click reload instantly, you'll instantly see it. And, there won't be as much of a confusion. You can even say live view of configuration data above, edits in the UI are reflected instantly here. Text edits apply after reload appearance. Text is pressed, which will refresh the user interface above. Isn't it nice when people leave good tool tips? If you go up to, now this is all just sort of experimental, you can go and click what did I change here, and it will tell you. You've edited the weapon supplemental data, the multicam one appearance, and the shape set. And so at that point you can make a decision, am I saving this or not? And you can click Save Configuration Files. I'm not going to do that, but it will tell you over here what has changed and where it was written out to. I'm not going to go through all of the details here. They are a little complicated. It will probably take a while, but one thing to just be aware of is that when you see this shape attachment data, it's saying that this body mesh, so it goes and sticks that suffix, but this is the name of the file of the data in 3ds Max, and this is the joint or link that it is getting attached to. So most of the time it is position, but not always. And that's how to think about this. You can have multiple shape attachment data, so you could attach the right rank and the left rank at the same time, and right, it's possible that actually that should be changed here, that this is not really necessary, that this could actually just be this. It would go and try to make patches R, LOD1 mesh, LOD2 mesh, and this might be able to save the shape set. Probably won't really change much in terms of the way of performance, but it would be a tiny change, tiny improvement. But yes, the idea is that this is the name of the mesh plus these LOD extensions, and this is where it's being attached. If you look at the weapon, for instance, you would see that there's a different form that's just saying, all 7 LODs are named small flash, and that the flash object should get attached to the muzzle. There's also this switch operator and switch value, and this variable that effectively is saying, drive this, the turning on and off of the flash with this animation variable. So lots of extra stuff in here. We have connection points, which are the ability to add some extra metadata without going into 3ds Max. So we've got a wounded carry system that we can see. This is where a character would wind up lying down if they're getting dragged, armpit, or moved by their armpit, or where they'd get parented if they were being fireman carried. There's some metadata here. We can also just, as you can see, edit it in real time with this nice little handy gizmo. And so that is the appearance editor. It is complicated. There is a lot of data here. You can look at the hands. You can see appearance effects. It's a challenge to understand, but that's sort of the overall concept here. It's better than just editing configuration files by hand. So we've talked about the content library, the geometry viewer, the appearance editor, the network settings. This is your log window. It is your friend. Try to pay attention to it. It will show you errors when we can't find LODs and shapes and files, so don't ignore it. There is a script editor. DI-Guy features a full binding of our C++ API into Lua. So for instance, there's a couple of globals, like this app, this character, this scenario. So this app, I can go and see the entire API, get current camera, and it will even show me tooltips. It will return a camera. As long as I name things reasonably, there are rules that are listed in DI-Guy scenario, but usually it's like the first name of the type. So DI-Guy view camera, it's camera. It will try to do autocomplete. It will try to guess what this object is, and in this case a DI-Guy view camera, and it will show you the C++ API that is available in the script. So very often you will just, there may be things, this character is currently the only character that can change, but in the character viewer it's kind of safe to do. So if I wanted to move him, I can just type in set position, 1, 1, 1. Oops, sorry. And now he's floating. Or I could set his orientation. I can save the script. Sometimes I want to have a specific sequence of things that happen, and I can just code them up in script. I can set his appearance. So yeah, the full DIGuy API is available here, or almost full. It's pretty extensive, as you can see. So that's the purpose of the script editor. If I want to automate fire weapon, there's a fire weapon n times. I didn't want to press it, so 100. I probably don't want to do 100. That's gonna, and the rest, the default values seem fine. So it can be handy for certain purposes. Playback control. This is sort of matching the rest of DIGuy. It can be a little handy if you're trying to debug certain things, like transitions, and you just want to watch the character a little slower, and we also have the ability to show other pieces of data. So that's the playback controls. They don't all make sense because it's just reusing the DIGuy scenario one, but they can be useful. PBR material tester. Does this still work? No, this is broken. Okay, we'll have to go and take a look at fixing that. But effectively, it shows you a whole bunch of silver balls. Wait, I'll just fix it. Okay, all fixed. Just the idea here is that these are different. This is the PBR values because we don't have environment maps inside this editor. It's not that spectacular, but it's just the idea that you could quickly look at some lighting information and get a sense for what values will do what for a DIGuy. A DIGuy shader. So we can hide that. And last user interface here is the texture viewer, which is new in 13.6. This shows all the different textures that have been loaded and a bunch of information about them, their size, their compression type, their GLID, which can be handy if you're debugging something. So that's all the information is here, and yeah, kind of nice to look at. Good information. And okay, time for a couple of menus. These are pretty self-explanatory. We've got a dark mode. Some people prefer this. Views, different camera locations, and then visualizations. So any menu that's got the little dotted line can be a tear off. Aim vectors, note they will only show up if the animation is an actually tagged with an aim variant. Otherwise they won't show up, but that can help you identify that an animation isn't properly tagged. Aim vectors should also wind up showing, animations or actions that are tagged as aimable should also wind up showing this user interface, which allows you to aim them and fire. There are particle systems that show up, you can see in the capture. Skeleton, pretty self-explanatory. Like I said, there's some extra stuff, these connection points. And at some point we might need to have that as an option to hide those, as it kind of adds up visually. Link names, it's a little bit of a challenge to get these to all show up, and not overlap each other. but you get the picture. This is the general skeleton of the character. And we do break out the connection points separately. This is the character bounds that we mentioned earlier that is used for broad frustum culling. We also have a local bounding box in case you need not spherical value. I believe this updates from the joint positions. It is also possible to get the link bounding box in case you want to do hit detection off of a closer set of values and not have to render and do a readback. Inverse kinematics for animations that have inverse kinematics active. This sort of shows where the initial location of the joint was and where the new one is and where the end effector wound up, or the target end effector location is. So if I switch weapons, you can see how the blue line is actually staying the same, but the end effector has changed. This is the pull vector. We kind of just try to pick a reasonable pull vector. Sometimes it looks good, sometimes it looks a little wonky, but yeah, can't be perfect. Movement data. So if we go and this is just some basic information about the character and what the desired value is versus what the resulting velocity, and I believe this might be the acceleration character has. I mean, people don't walk perfectly smoothly, and this is sort of a representation of this. This is the velocity that the end user is asking for, and this is what we managed to generate. Show state info. So this is a debug label, and it allows us to sort of see if the character is doing a transition, what animations are actively playing, how far into the animation it is. You can use this along with the playback controls to sort of step through it for debugging purposes. So that is the state info. Wireframe, pretty self-explanatory. Light editing UI. Oh, I forgot I even did this. Okay, it's a nice little gizmo that sort of matches what's going on here, but we'll integrate into the viewport. Show all LODs. So this is a tool that's pretty handy actually. So right now what you can see is that the middle guy is the one with the star. That's the current, this is he's 3.9 meters from the camera. He's currently using LOD 1.78, so it's somewhere between LOD 1 and 2. And we've bolded that LOD. As you move further out, you can see that now he's doing LOD 2, 3, and now 4. So, sorry. This is LOD 1, 2, 3, 4, 5, 6, and 7. So you can see them next to each other, but you can also see them, you can also see it procedurally and get a sense of what's going to actually happen as you move. And it appears that this guy has some UV problems on the lower LODs, and we should report that to the artist. So this is a nice tool for just understanding, how many polygons. Probably I should add draw calls to that, but maybe next version. And the action info, I think this sort of overlaps a little bit with the movement data, but we were discussing variance and directions. It sort of just helps debug some of the metadata of the characters in this tool in case something seems like it's wrong. You can double check it here. And I think that's getting close to the end. I think, let's see if the next thing I want to talk about is the component system. Just a quick, oh, on his head, sorry. His jacket. So you can see, and let's just make a few more of them. So in this case, we have a number of templates, just two, color 1, color 2, but you can make as many templates as you want, and the artist can adjust the shirt color. You can set it to black and white, in which case the color shifts will all go together. And this is the range of colors that it will generate. And you can kind of just click this and see, okay, what's going to happen here. Now if I just wanted a mostly red shirt, shift this up, lower the variation, hit randomize. Now we have a bunch of red shirts. You know, subtle is good. But you know, effectively you can control all of the different pieces, each of which is defined in Photoshop. You know, there's a layout file, and you know, there's a layout file, and we're able to specify like the red pixel should be 18, the jacket 34, or anything up to that. And there's a pixel shader that will go identify, based upon the color, where to look up into the other file, into the adjustment that's on a per shape basis, and change it. So with this, we have the ability to have, you know, characters that feel like there's hundreds of them, even if there aren't really. You know, in general, you know, the DI-Guy content library, the goal has been to allow us to take a limited amount of content, and by sort of setting up, here's the head, here's the hands, here's the body, and trying to make sure that they all have ways of picking reasonable other pieces, that we can really generate a lot more content. So all these guys are wearing, you know, same jacket, different heads. You know, we've tried to make sure that everybody, you know, fits there. If I start doing appearance mix, you know, suddenly we can make a whole town of people, including the Joker. That's new. Might want to remove that from the default, but it's kind of cute. But a whole town of people from not a huge amount of initial content. So thanks. That's the tour of the character viewer. Thanks for your time.